Hello everyone. Today I'm going to introduce our work, New Techniques for Pairwise Symmetry Breaking in Multi-Agent Pathfinding. This work is recently published at ICAPS 2020. In the multi-agent pathfinding problem, we are given a graph and a team of agents, each with a start and a goal location, and we are asked to find collision-free passes for the agents while minimizing the sum of their travel times. There are many algorithms for solving this problem, and CBS is one of the popular algorithms for solving multi-agent pathfinding optimally. It works as follows. It first plans the shortest path for each agent by ignoring the collisions, like these two paths. It then checks for collisions. Here, the two agents collide at location A at time 1. It then resolves this collision by saying either agent 1 cannot be at A at time 1, or agent 2 cannot be at A at time 1. And in each case, it generates a child node with a new constraint, and replan passes satisfy the new constraints. Then CBS will repeat this procedure by choosing one of the child nodes and checking collisions again. So it will traverse this high-level tree in a best-first manner and terminate when it finds a node with collision-free passes. In last year's AAAI, we introduced rectangle symmetry for 4-neighbor grid multi-agent pathfinding. In the rectangle symmetry, the two agents has multiple shortest passes to reach its goal locations. However, every combination of these shortest passes has a collision inside the yellow rectangular area. So to get a collision-free passes, one of the agents has to wait for one time step. But CBS has to try many combinations of these shortest passes before it realizing that one of the agents has to wait. In this work, we introduce another two pairwise symmetries. The first one is corridor symmetry. It happens when two agents want to travel through a narrow corridor in opposite directions at the same time. These are the shortest paths for the two agents. They collide in the middle. Then, if CBS asks agent 1 to replan, agent 1 will simply wait for one time step and enter the corridor again, so they will collide at location B at time step 3. If it asks agent 2 to replan, then agent 2 will simply wait for one time step and enter the corridor again, so they will collide at location C at time 3. So eventually, this will be the final tree generated by CBS. It contains 16 leaf nodes at the last layer, and only the leftmost one and the rightmost one contain collision-free passes. And if the length of the corridor increases, the size of this tree grows exponentially. Another symmetry is called target symmetry. It happens when one agent has already reached its goal locations, and later another agent travels the goal locations of the first agent. For example, here, agent 2 reaches goal location at time 1. Then at time step 3, agent 1 reaches the goal location of agent 2, so they collide here. If CBS asks agent 1 to replan, it will simply wait for one time step and then collide with agent 2 again. If it asks agent 2 to replan, it will find a set of collision-free passes. But unfortunately, the cost of this set of collision-free passes is larger than the cost of the passes in the left child node. So to prove the optimality, CBS has to first expand the left child node. And this will be the final tree generated by CBS. In this work, we introduce reasoning techniques to detect the corridor and target symmetries efficiently. We propose new branching method to resolve these symmetries in a single step instead of generating such a large tree. And we also prove that our reasoning methods can preserve the completeness and optimality of CBS. Now let's look at some results. Here, RCT represents rectangle, corridor, and target reasoning respectively. The figures shows the percentage of solved instances within 1 minute, so higher is better. We can see that both corridor reasoning and target reasoning improve the performance, and the combination of them performs the best. If you are interested in this work, please refer to our paper for more details, and thanks for listening.